In question 7, which one of the following functions does not have an inverse function? So one of these doesn't have an inverse function. So to have an inverse function, it needs to be, the original function needs to be one-to-one to start with. So that's really all you have to do with these. Figure out which one is not one-to-one to start with, and that will be the one that doesn't have an inverse function. So looking at a, first of all, this is a linear function. So basically y equals f of 2x minus 5. Gradient of m equals to y-intercept c equals minus 5. And that's my timer going off. And so to draw the graph of that, so gradient of 2 passing through y equals minus 5. If you do a vertical line through it or a horizontal line, both of those lines will cut this line at only one point. So it's definitely one-to-one, one x value for every one y value. So this one does have an inverse because it is one-to-one. So b, x squared y equals x squared. So, or g of x equals x squared. So that's centered on, or the turning point is at 0, 0, like that. Here are my axes again. I'll put them in so I give you some, or lead by example and remind you to always put them in. Then you're never going to forget them in an exam. And this here is always the domain. So the domain goes from 0 inclusive up to positive infinity for the x values. So 0 is this point here. So marking that in blue, that point there, and then it's all this part of the graph here. So no matter where you do a vertical line or a horizontal line on that blue part of the graph, which is the graph of this function with this domain, it is going to be one-to-one. So that one will also have an inverse. So maybe I'll put tick for inverse. All right, so C is not the answer. Sorry, B is not the answer. And looking at C, so the h function is equal to x cubed. So when it's y equals x cubed, that's just your basic cubic graph that does something like that. And no matter where you draw a vertical line through that, it's going to cross the graph only at one point, and its domain is all real, so nowhere on that graph does it double back on itself or anything like that. So once again, setting a good example, y and x, so there's the graph of that, and that is also one-to-one, so that does have an inverse. So looking at D, so this k function with this domain is, so I'm just going to make y equals the square root of 4 minus x squared. So what you can do with this is do this. So square both sides and you get y squared equals 4 minus x squared. And then add x squared to both sides and you get x squared plus y squared equals 4. And this is a circle with center 0, 0 because it's x plus 0 squared and y plus 0 squared. So 0, 0, and this here is the radius squared, so the radius is going to equal 2. Now when you draw that, so centered at 0, 0 and going through 2, 2, minus 2 and minus 2 there, which would give it a radius of 2, so something like that. That's not a bad circle. And y and x, and coming back to the domain, the x values are from minus 2 to 2. And this is the positive square root, so really you only want the top half of that graph, which would be the graph of this function here. And if they had minus here, then you would only have the bottom part of that graph. And if you wanted the whole thing, you would have to go plus and minus. So there would be two different parts of the graph that would actually be, in fact, one circle. So the positive y values are just this top part. So once again, using the blue marker. So there, that's the graph, and it's including the x value of minus 2, which would be this point right here on that intercept, and also positive 2 for that one. So that part of that circle, if you do a vertical line, it's definitely one-to-one, but if you do a horizontal line anywhere down here, it's going to cut in two spots. So that means that for example, you know that x value, that x-intercept's -2, and this x-intercept up here is 2. So say this x value here is, say, minus 1.8. And this one here would be positive 1.8. So that's at this point right here where that horizontal line intersects the top half of the circle. So there are two x values for that same y value. So because the line's horizontal, the y values are the same all the way along it. So you would have, for this point of intersection, you would have x equals 1.8, comma, let's say y might be, say, 0.4, for example. And over here, for this point of intersection of the horizontal line and the circle, you would have minus 1.8, comma, and that same y value is 0.4. And so what you have is two different x values for that same y value. So you have 2 to 1, which is not 1 to 1. So two x's for each y on certain parts of that top half of the circle. So that function, that top half of that circle, is definitely not 1 to 1 with the domain that they've given you here. So D looks like it is not, it won't have an inverse function, so therefore it's the one that you're after. So at this stage I reckon D is definitely the answer. And looking at E, you have a hyperbola here, 2 minus 3 on x, so I'll do it 2 minus 3 on x. So this is your basic -1 on x type of hyperbola. So my axes are slowly getting better, I believe. So your 1 on x graph is in these corners. When it's minus something on x, it's in these two corners. And this 2, it's also, yeah, it's just here and here. And then this 2 is like going +2 at the end instead of having 2 here, which moves the whole thing up 2. And you have a y asymptote or a horizontal asymptote. It's actually a horizontal asymptote, and its equation is y equals 2, and the graph will be in this corner and in this corner here. So even though they've restricted this to r plus, which is just this part of the graph here, this blue dotted part here, so that part of the graph is definitely 1 to 1. No matter where you draw a horizontal or vertical line through that part of the graph, it's only going to cut at one spot. So that is definitely 1 to 1. So that means it does have an inverse. And so all of those verify that D is definitely the answer. So that's one way of figuring out this type of question. Usually, well, drawing the graphs is kind of the easiest way. So you've got to be good at drawing graphs of functions. So D is the answer, and that's how you do this question.